The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello, everybody. Thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
We are the Hawaiian Volcano Education and Resilience Institute, HVERI for short. A lot of people know us from the 2018 eruption of Kilauea in the Lower East Rift Zone. Working under Hawaii Tracker on the Facebook group. Since then, we've been trying to carry on and take the lessons, the hard lessons that were learned during that eruption and try and prepare for the next major disaster that comes to our island.
Yeah, and so we do that through two different programs. One is volcano education, and the other part is digital resilience, which we address through online groups on social media. So the way the two programs work together is that the social media networks end up being a distribution pathway for all the information. And having that network in place means we can provide more than just volcano education, but any other preparedness information as well.
What we were working for really came about in the Mauna Loa eruption in 2022. Within hours of that eruption starting, we had the mayor, Mitch Roth, we had USGS HVO Ken Hahn on the stream trying to help flush out a little bit of the ongoing because it's so new. It's completely different from our previous major eruption, which was 2018.
One of the things that Talmadge and I were talking about was how do we deal with social media? It was something we needed to figure out and get right. Our job is to get information to the public and make sure that the public get it as well as possible and as correctly as possible. When Philip and Dane started coming to and live streaming the meetings, it was great because we were reaching more people than we normally would. So when the eruption actually happened, we had this relationship. The interviews we did during the eruption, the most fun ones were the ones with Philip and Dave because they were more relaxed, and we knew we were getting to the local community, and people were asking questions. So those were the best. I think I just want to really give a shout out to those guys and how we worked as a team on this eruption. It really worked out well, and we got to a lot of people we wouldn't have normally gotten.
Aloha, everyone. I'm geologist Philip Ong, here with Mr. Dane DuPont from the nonprofit HVERI, the Hawaiian Volcano Education and Resilience Institute. Today is Thursday, July 25th, 2024. Kilauea has been shaking quite a lot this past week. We'll get all into that. But first of all, how are you doing today, Dane?
I'm doing pretty good, you know. The volcano's been keeping us pretty busy this week, huh?
Sure has, yeah. Been a great job by the USGS putting out lots of information and maps and things like that, although there's not much to actually physically see. Everything's happening underground so far, for the most part. But there's plenty of data now for us to pour through and to look at, and some historical context to talk about as well. So we'll get into all that. Anything else you want to mention up top here before we get into it?
Yeah, there's been a lot that's been going on over the past week and on Kilauea. So if you have any questions about the activity or historical context, go ahead and put them in the chat, and we'll try and get to them. We'll be doing 2 segments today of Q&A, I believe.
We'll do the Q&A at the end. Yeah, after we present all the information.
All right.
So, all right, let's get into our summary then. Let's rearrange our screen here for you guys. We'll make it look pretty. Aloha, everyone. This is our Hawaiian Volcano summary for July 25th, 2024. Over the last 4 days, there's been an intrusion of magma into Kilauea's Upper East Rift Zone, accompanied by over 1,500 earthquakes. It has caused uplift of the ground in this area between Pauahi Crater and Maunaulu, centered more or less here, as you can see on the background image from the USGS based on satellite radar data here. So there have been 4 major pulses of earthquakes in the last 4 days. They've progressed down to this bend of the rift zone between the Upper East Rift connector here and the Middle East Rift Zone at Maunaulu. And this is an area where many intrusions have a hard time turning this bend in the rift zone. And it seems like this one may be experiencing similar effects. This 4th pulse happening today has migrated back uprift to Koʻokoʻolau Crater right in here. And it looks like the ground deformation may be slowing as we speak. There's some complexity in here. I'll show you guys this raw map of the radar imagery of where the ground is swelling. And you can see the inflation center right over here, not far from the Maunaulu Fissure Trail in a national park, and west of the Maunaulu lava shield itself. Now, there are several faults in this area. There's one right here that seems to be one of these major faults of the Kauai fault system, which is largely to the west here. But you can see that these rainbow fringes are actually displaced and offset by this fault, suggesting there's been movement here in the fault as well. Not only that, beyond our normal concentric bullseye pattern, we have some of this kind of fingerprinting swirling going on where some of these fringes turn back on themselves like that. So there is certainly some complexity of movement happening in this area near the fault where the ground has been swelling. The nearest tilt meter is near the escape road by Pauahi Crater, more or less in here. And it has been the main signal that we see expressing ground tilt. The scale here is massive. We're looking at 120 microradians from top to bottom on the escape road, with our blue vector, which is pointing north-south, dropping from around 0 to more or less negative 55 or so. So a huge amount of ground tilt down in the north-south direction. Similarly, there's been some tilt in the east-west direction, but not as large a magnitude over there. Here, if we zoom it in, you can see the various pulses. There was a first one on the 22nd, the second one on the 23rd. In the times in between, deformation progressed, continuing, although not in as quick a pulse. And then we have our 3rd pulse yesterday and our 4th pulse this morning. And as of right now, it appears to have been flattening. And so we'll see if the dike intrusion has another phase in it still, or whether it is in its waning chapter at this point. This is on the rift zone. Further away at the summit, this is the Uekahuna tilt station, which after a small delay on the 23rd began to deflate and is now suggesting that magma is draining from the underground summit areas to feed this Upper East Rift intrusion. This is visible also in a pattern at Sand Hill. We're here with a much larger scale we're showing a similar amount of tilt drop, both from the main summit caldera area, as well as in the green component here from that southwest rift connector area, both of which have been building up with pressure following the eruption on June 3rd in the southwest rift. So all this has led to earthquake counts that are close to 500 per day over the last couple of days, which are similar to what we saw during the last pulse of intrusion in the Upper East Rift at the beginning of July, end of June. That one did not cause an eruption, and that was related to inflation of the summit reservoir, whereas now we're actually seeing ground deformation on the East Rift itself for the first time since the 2021 post-2018 era. So those are the earthquake rates for the last month. And from the USGS update today, I'll just skip down to where they put out the analysis. Oh, maybe this is the wrong one here. But essentially, there are three possible outcomes of what the volcano could do. The intrusion could continue underground, still swelling, and without any eruption. It could lead to a small eruption in this Upper East Rift area. However, the USGS has noted that there have been 50 intrusions in this area in the past, of which only 5 eventually erupted. So the more likely outcome at this point seems like it remains an intrusion, unless the third option being that the earthquakes migrate further down a rift into the Middle East Rift Zone proper. And once they make that bend and make that turn, then that opens a different set of possibilities and scenarios. So we'll have to wait to see what happens, but that is a story here on Kilauea. Mauna Loa is much quieter. Well, first let me show you the map of Kilauea. Here's where the earthquakes cluster just for the past week, colored by depth. So this is that area. You can't even see the craters under the Upper East Rift beneath all these earthquakes. All right, so now to Mauna Loa, which has an earthquake map that looks much more sparse, with a few events showing background activity over the last month. But looking at all the signals, including the GPS, we don't really see any change in the data. So very little obvious influence of Kilauea on Mauna Loa at this time. And that's our Hawaiian Volcano summary for July 25th. So let's move on to some observations. So let's get that here. And we'll start off by looking at the webcams that perhaps all of us have been looking at, refreshing, as I just did for the last several days here. We'll start off with this KO camera, which is that temporary camera placed on Maunaulu looking northwest towards the Upper East Rift Zone, towards this earthquake swarm zone. Presently, it seems to be a cloud in the path of this view here. So we can scroll down to look at the last 24 hours, and we'll wait for the night to cycle through when there was no light whatsoever coming from below. Here is a landscape in the morning before the clouds come in later in the day. So not a whole lot to see there, but that's one camera we can look at. The other one is the MU camera. That's on Maunaulu facing east. Looks like there is some mist or some water on the lens there, but there is a view from earlier in the day as well from that side. This one looks further down the East Rift Zone itself, towards Pauahi Crater and Kapoho, and well, not that you can see that far on this grainy webcam, but there's Pauahi Crater and Kananuyohama lava shield in the view of this frame. Nothing there as well. It is worth mentioning, well, let's turn that ugly, but this is the K2 camera from Uekahuna Bluff from the USGS HVO. This is a camera on the USGS building that is being, the former Jagger Museum, that's being decommissioned. And it's being repositioned. Let's see here what's going on with the view of this thing. It's been repositioned to look further over to the southeast towards Maunaulu itself. So if there is an eruption that the other cameras don't catch, we maybe have a different point of view. This in the background is Maunaulu lava shield itself, right in there when the view allows it to come in. So you can see why that landscape sticking above the surroundings often gets fogged in. So if an eruption happens between there and a summit area, then that's this zone right through here. This is Koʻokoʻolau Crater in the background right in here. I'll wait for this to cycle back through. Koʻokoʻolau is this one right in there, that little shadow. So the path of the East Rift flows more or less like that to Maunaulu on this image. So it would be in there where you'd see any fissure if there were one to erupt. So that camera as well. And I've also been curious about whether there'd be a summit response. So I've also been checking the F1 thermal camera here. Let's put this back to our proper size. Just to see if there is any draining from the summit. Perhaps we'll see some relaxation or cracking on the lava crust on this camera. Since it's hard to see across day and night, I like to look at the thermal camera, and you might see some extra hot spots opening up were that to happen, although I have not seen any indication of that so far. So that's the visuals we have to share on various web cameras. If something were to breach the surface or affect the surface, these would be the views we're looking at for our clues. So those are our observations today. And I think what we'll do next today is we'll switch the order a little bit and we'll put up a volcano watch from this week. Because Volcano Watch released just today is a nice summary of this events that have been happening. And so we will go through that in a little more detail than we usually go through Volcano Watch today, since I believe this was very well written. So the Upper East Rift Zone has been shaking with more than normal, with nearly 1,500 earthquakes between July 22nd and 25th, prompting closures in a national park. What's causing it, and what should we expect to see happen if it continues? And that's where we're heading with this. Here's a map we showed at the top of the update, combining the earthquakes and the interferogram. That's the ground changes detected by satellite radar. And what they say here, let's see, I'll try not to read every single line on here, right? But talks about the Upper East Rift Zone being a good indicator as a magma pathway. And that's why the craters exist there. They're areas that have hosted magma that has drained away to create craters, and therefore magma has been underground there, and therefore it's a magma pathway. So there were earthquakes at a low rate in the Upper East Rift Zone within a few days after the June 3rd eruption on the Southwest Rift. And it really escalated, as I previously mentioned, at the beginning of this month, July 1st and the end of June, where there were a different set of 1,500 earthquakes beneath the Upper East Rift Zone. That swarm was related to pressurization of the magma storage areas beneath Kilauea summit, which were inflating following the June 3rd eruption. And so we're talking about the whole summit recovering from that very brief Southwest Rift eruption, which was more like a leakage than it was really an eruption. And it didn't really accomplish a lot of work in relieving the pressure as it quickly resumed after the fact. On July 22nd, another swarm of earthquakes began in the Kilauea's Upper East Rift Zone and is ongoing. Earthquake locations have shifted, first being distributed along the Upper East Rift Zone, then concentrated near Pauahi Crater for those 2 days of July 23rd and 24th, and today on the 25th, clustering to the northwest near Koʻokoʻolau Crater. That should be a K right there, on the morning of July 25th. Pulses of intense earthquake activity have been accompanied by changes in ground motion. So what they mean is the earthquakes have been pulsing, and the ground deformation has also been variable, not just in the Upper East Rift, but also on Kilauea summit. As earthquakes increased in the Upper East Rift Zone, Kilauea summit began to deflate. This indicates that magma is moving from the summit storage regions into the Upper East Rift Zone, likely being intruded upwards into planar crack systems called dikes in the area between Pauahi Crater and Maunaulu. So dikes, planar cracks, I've called these blades before, like a blade of like a long, skinny feature that's really skinny. It can be really tall and really wide, but really skinny, so like a blade. And they follow up that this type of activity isn't surprising for Kilauea. During the past 50 years, there have been about 50 intrusive episodes like this in the Upper East Rift Zone. And in each case, magma moved underground within the rift zone, the Upper East Rift Zone, causing earthquakes and deformation, like now, but only 5 of those resulted in Upper East Rift Zone eruptions. They note 68, 73, both in May and November, 74, and 79. These eruptions were relatively brief, each lasting for hours to about a month. Now, not to be picky here, but 50 years was actually goes back to 74. So really, of this list, there's only 2 on here, but really the point is taken 5 really within the recent past. They note an intrusion on Father's Day in 2007. They believe that's the most recent significant intrusion. I would have some other candidates to propose as well, but that was an important one. Father's Day 2007, with an earthquake swarm near Maunaulu, accompanied by changing deformation rates. What was different on that one was over the following days, earthquakes moved down a rift towards Pu'o'o in the middle portion of Kilauea's East Rift Zone. Cracks and steam vents formed, and a small amount of lava erupted in the Middle East Rift Zone, downrift of Maunaulu. Right on Kananui Ohamo was when that one was, 2007. There was also one in 2011, Kamoamoa fissure, which erupted for 4 days on the west side of Pu'o'o. You could also bring in the Thanksgiving Eve breakout in 2014 that eventually led to the Father's Day flow that went to Pahoa. There are all kinds of other fissures that happen in there. But maybe we're putting the dividing line right on Maunaulu, so we're looking at what happens just to the west of that as opposed to just to the east of that. So in 2007, it began to the west and then moved to the east and then transitioned from being Upper East Rift to being Middle East Rift, as was our third possibility of what could happen in our situation today. So they note that the Upper East Rift also connects with a Kauai fault system, which is complicated. Magma can move into it, though eruptions have been rare. They do note that in the present activity, deformation related to the ongoing swarm is localized along a strand of the Kauai fault zone, which is something that can occur when the fault zone is stressed. Right? So the fault is under stress, it's under pressure. That's why there's so many earthquakes. It's pressurized in a way where it's deforming mostly on, it seems like that southernmost strand would be my guess, but one of the strands in particular. And here is where they go into, it could result in a brief eruption in the Upper East Rift Zone, which has happened just a handful of times. It could continue to grow underground, which has been the most common scenario in this area in the past. Or it could also migrate to the east, further down the East Rift Zone of Kilauea, which in turn may or may not result in an eruption. If that were to occur, there would be earthquake locations migrating to the east past Maunaulu. They note that on the Middle East Rift Zone is where you have many long-lived eruptions, such as Maunaulu lava shield, Kanenui Ohamo lava shield, that's the one right next to Makapui, and Pu'o'o as well, examples of long-lived eruptions in this area, months to years, with shorter duration eruptions also possible. After our break, we'll go through the eruption history of that rift zone on a map, so we can just put it all out there for you guys to make your own pattern matching. So what they say to finish this up is intrusions are common. Lava flows are how volcanoes grow externally. They also grow internally via intrusions. I, in the past, have turned out a very rough guess of maybe 50-50, how much it grows underground as opposed to on the surface. That might be an average across all the parts of the volcano. The Upper East Rift in particular doesn't erupt so much, so it's extra intrusive. And usually what happens there is almost, in this case, 90% of the time is an intrusion and not an eruption. So that is it for Volcano Watch for this week. I thought this was a good summary of the last 4 days of activity here in Kilauea. All right. So with that, we will transition to looking at our recent earthquakes. So I'll bring up first our island-wide map of earthquakes. This is for the last 2 weeks. These earthquakes are colored by depth, with the blues being generally deeper, and greens as well, and the reds and oranges being shallower, although orange-yellow is more intermediate, and reds are really the shallow ones. So that's the last 2 weeks. We have our usual pattern, lots of colors scattered fairly widely across the background of the map. That's our background seismicity. As the island settles, following this very dynamic right across the Pacific Ocean here. If we come back to just the last 2 days, now we'll see the cluster on Kilauea, which we'll examine at length here. We see a couple on the southeast flank of Mauna Loa, perhaps some minor adjustment to Kilauea here to the southeast, although not expressing any monitoring signals as we recapped in our update. And then the blue dots are long-lived deep earthquakes in Pahala, the magma source for the volcano that comes through at depth and moves through some pathway, perhaps some of it going this way and then coming upwards to feed all of the surface shallow activity that we see today. So let's come in further on Kilauea here. So that is the last 2 days. And you can see that unlike that week-long earthquake map we showed earlier, we really have no activity whatsoever in the South Caldera area, which is a marked change from all of the recent months we've been seeing Southwest Rift activity. So this is the main shift USGS is referring to, everything in the Upper East Rift. You can see there's almost 2 segments here. There's a segment that's delineation this way, and then more or less in here, it gets fatter coming across. And so however you would like to draw around this, something like that. It almost has made the bend, right? One direction going this way, and the other one bent following the rift zone that way. And that's the pathway that magma has to take to intrude the Middle East Rift. And when you look at the satellite image, you see these dark lines. These are the cracks of the Koʻokoʻolau fault zone. Those are the ones that allow the summit to act like an accordion and expand and contract as it needs to, with magma swelling below it. And this is the structure of the East Rift as well. So that trend of north 67 degrees east is what you see more or less trend of all the Koʻokoʻau zones. So those cracks exist across this whole area of the bend in here. And so as the magma comes and pressurizes this area, it's coming across these series of cracks, and it's going to start to inject into those, perhaps both ways, although here the trend seems to be more to the east. And perhaps not all of those trends actually connect further into the Middle East Rift. Right? So that's where this has to become a progression of activity of the ground. The magma comes and starts filling cracks, works its way further, fills more cracks, works its way further. In the meantime, the pressure is building behind it because it's having to propagate the leading edge further and further away from the magma source at the summit. And eventually, it seems like the earthquakes seem to slow their eastward migration and repopulate back to the west. And so the pressure building back uprift here as well. So there are other ways to look at this, but we'll start off with just that general overview of the landscape here. That's the last 2 days. Recently, I've been having this setting more in the last 2 hours because the swarm has been so intense. And so in that sense, you can see here that the more recent activity has been focused in this Upper East Rift connector between Hiaka craters, and this is Puhimau over here, with Koʻokoʻolau being right in the middle, right in there. There are a couple earthquakes further over towards Makapui, suggesting that work is still happening to open those pathways into the Middle East Rift. But that status is currently unclear here. So that is the earthquakes plotted by depth. I also like to show this other version of the map plotted by time. So let me show you the key for this one. Reds now are the last hour, orange is the last day, and yellow is within the last week. I just have it for the last 1 day. Presently, if I go to the last week, you see all the yellows populate, including some of those South Caldera ones early on. And so that's a change from the whole week to the last few days, and the last day in particular right here. So this is showing right now earthquakes by time. So presently it's 5:31 p.m. It looks like 5:23 p.m. was a last event here, 1.7, 5:18, 2.7, 5 o'clock, 1.8. And you can see it goes on from there. All these, I'm scrolling past, I'm back to just noon today right in here. So very high earthquake counts. If I pull it back to just magnitude 2.5 and higher, just for today, you can see a little bit tighter cluster here where the ground is adjusting the most, including that little bend, and including one event over here near Kananui Ohamo. So similarly, I can come back to this one. Let's take it for the last 2 weeks again. And now all I want to do is filter out our magnitudes that are less than magnitude 3. So here are just our magnitude 3s that we've had in the last couple of weeks. And of these, following that similar pattern there, including a bend, and there is one, the 3.4 that occurs on the east side of Maunaulu, near the old site of Pauahi Crater, an old crater that's now buried in lava. Okay, so that's the earthquake distribution there. What I can do now is just play back an animation. So we're now at the Iris interactive earthquake browser. And what I've done here is put in a time range back to the 22nd, which was Monday when this began. I have filtered my depth to only the events shallower than 10 kilometers. That's the ones we're interested in here. And that gives me 830 earthquakes to go through here, right? So we're able to animate the earthquakes, which is why I'm using this. And so I'll play this and let it loop here, and you'll see the first day before the swarm comes in with the background activity. Here comes the swarm, focusing by Pauahi Crater. Now it starts propagating or filling the area, and on the third day, it starts propagating further uprift to Koʻokoʻolau. So there it was. Here it is playing one more time. See, it comes down, tries to make this bend, starts pushing over, finally starts getting more events further to the east, and then starts propagating events back to the west. So pretty fascinating pattern. We'll see what comes next here. That's why we say this is ongoing. It's an exciting time. We can also from here get statistics of the earthquakes on this map. So of these, it is telling us that 3%, 24 events were in a magnitude 3 to 4 range. There were almost 400 in a 2 to 3 range, and similarly in a 1 to 2 range. Only 6 showing 0 to 1, which tells you that all the ones lowered magnitude 2 are not really getting counted to their full extent. They're getting lost in the noise of other events actually occurring. So we actually probably have more earthquakes than these numbers are suggesting here. And so that pattern of backfilling is interesting. I thought I would pull out one page from one of these USGS papers. This is professional paper 1806. And I won't go into any other context apart from just to highlight this sentence right here. During the 1977 to 1982 inflation period, and I'll just caveat, this was following the 1975 South Flank earthquake. That was the last big earthquake before 2018. So a similar post-earthquake recovery setting then as now. So during that time, the cement reservoir was magmatically connected with the Upper East Rift Zone down to a conduit barrier located near Maunaulu. This barrier was an active stopping point of earthquake swarms progressing down rift from 1976 to 1982. In addition, there was aseismic, that means no earthquakes, aseismic passage of magma along upper rift pathways to the central and lower rift preceding, well, they really mean the middle rift here, the central and middle rift, preceding the eruption of 1977, which is Pu'ukiai above Kalapana, not quite the lower rift there. Earthquake migration with time shows that more than half of the intrusions during that period began near Maunaulu and migrated both uprift and downrift simultaneously with resupply from Kilauea summit. And here is where it really struck me while I was reading this. Because the summit was deflating at the same time as magma was actually moving uprift from Maunaulu, it's likely that intrusions were forming dikes within a shallow pathway originating beneath Maunaulu, while magma was being resupplied without earthquakes from Kilauea summit via another deeper east rift zone pathway. So a lot of things going on in there. Multiple pathways might come into play here. We have a similar pattern of when it backs up at Maunaulu, it basically shallows and goes back uprift, but it's doing so at a slightly different depth. So it's injecting magma shallower. And that's pretty similar to what we have going on now. So not unheard of, the pattern we've just seen right here. So that's our focus on the earthquakes in particular. We will more generalize the monitoring data here. So let's start off with the USGS information statement, which was released yesterday, Wednesday at 4 p.m. And this is just a recap of all and at that point in time, the 3 days of activity up to that point. So I will not reread everything that we've already covered in our update today, but they do highlight when a pulse has actually occurred. The first one at 11 a.m. on July 22nd on Monday. The next one was in the morning on Tuesday morning, 3:30 a.m. on the 23rd. The third one was Wednesday at 10 a.m. Each pulse lasted about 2 to 3 hours, but seismicity and deformation continued at levels well above normal in between those pulses. So this was as of yesterday, so the fourth pulse had not come yet. And they go through here with their 3 scenarios as well. Intrusion grows, Upper East Rift eruption occurs, or the intrusion moves east. They discuss all the communication with the national park and the civil defense. The national park has closed much of the area affected. So no trails, no campgrounds, no roads are open in that area. They have repositioned the camera as we mentioned earlier, and so they're hoping to catch any activity at the surface should it happen through those cameras. Yeah, so I will not read any more from here. I will move on to the update from today, which mentions another pulse this morning around 4 a.m. that was still ongoing as of 9 a.m. So they still note additional pulses or swarms may occur with little to no warning and result in either more intrusion of magma or eruption of lava. Yeah, so that's really the key of it. They do note the most recent gas emission rate, sulfur dioxide, of 65 tons per day on Tuesday. That's the background rate of gas, so no extra gas is coming out. And I do note that in the middle and lower East Rift Zone, there are low rates of earthquakes and deformation. So that's the current situation there. Coming up to the current monitoring data, which we'll look at next year. So let me just give this a reload since things are so dynamic right now. We'll start off with the summit signal where the magma is draining from. And this began with a delay. The actual onset of activity was on the 22nd, maybe earlier than that, maybe in here. You see some little spikes on the blue line, which are the earthquakes jolting the tilt meter, which in these cases is resetting back to where it used to be after being shaken. But you still see where the big earthquakes occur. There's another few of them over here. But on the 23rd is when the signal begins to deflate. If we look at the scale here, we're starting off somewhere around just below 4 microradians, and we're ending up somewhere just above -8. And so let's call it 3 to 8. We'll call it 11 microradians in total, top to bottom, which is significant, but it's not massive. It's not like the tens of microradians or hundreds that we've seen with eruptions in the Southwest Rift or intrusions in the Southwest Rift or to 2018, the Southeast Rift. So it's moving out of there pretty slow. It is gathering some volume over that 3-day period there, but overall fairly slow to only reach 10 microradians in 3 days. All right, so that's the zoomed in view, this 1 week data. And then we'll zoom out in a minute here. But looking at the earthquake counts, you can see these rising in earthquakes per day steadily all week. This most recent bar on the right may end up lower, but usually the last day that's not a full width is not a full count. So it's hard to compare the ones on the edges to the 6 that are full data in the middle here. So the 6 we can see steady rise here in earthquakes. The red line is actually measuring cumulative moment, which is a measure of the total amount of energy released. So this would be like 1 times 10 to the 22nd there. So usually if you have one big earthquake, this will jolt things upwards. But when you have lots of small earthquakes, that's what you get. This pattern looks like this. So that's really why these plots are on here. This is telling you a combination of not only are we having a lot of earthquakes, but they're actually, especially here, accumulating a lot of energy. A lot of big ones are happening as well and making a lot of change. So you can see that's still happening here today. Looking at the depth versus time plot, at this scale, we have all of our activity in this orange band. So all we can really see here is that the dots are smaller at the left end earlier the first week of the month, got bigger the second week of the month, got larger here. I'm sorry, this is the week. So I guess the first day of the week, second day of the week, and then here, Monday, Tuesday, and growing in size and overlap of these data points over here on the right. And not really much of a response in the deep zone or the intermediate zones, although you do see the yellow dots plotted on here too. So this cross-section is capturing all the earthquakes in this map, even the ones way down here away from the rift zone. They all project onto that cross-section. And you can see the yellow ones are much more dispersed across the map area. Right? It's really the orange ones that we're concerned about associated with the current activity. So this map isn't giving us the resolution our other ones did, so I'll just continue past. In a deeper cross-section, here's how the magma plumbing system sits. The deep earthquakes in Pahala feed some pathway to Mauna Loa, to a volcano formerly called Loihi, now called Kameʻehua Kanaloa, and to Kilauea through some path perhaps like this, where it joins other pathways of magma that come up from depth as well. Right? And those feed the shallow system of Kilauea, which is a summit, and its rift zones, both. And then there's a south flank, and that's what the cross-section is showing us here. Just catch a little review in case we have some new viewers joining us here. For the last month, now we're zooming out on that plot. So here's our last few days of deflation. You see it's fairly minor compared to how much we inflated even over this past month. Now, we do still have this remnant extra wiggly signal here at the start of the month. I suspect this was because they were preparing to recalibrate this tilt meter, and maybe there was some extra noise in that vault where the instrument's kept. Once it was recalibrated here, you see that pattern disappear. But we're also warned that for a few weeks, the absolute numbers of this tilt meter should be taken cautiously because it still has to settle and the values may not be as accurate as they will be later on. So we can say that more or less we've had there 10, 15 microradians of inflation, but we can just say overall it's been inflating a lot, and deflating perhaps not quite as much as it inflated since that happened. It does appear that on this most recent summit plot that we are finally leveling off there. We'll bring it to the top one where it's more zoomed in. It does seem like we're finally leveling off here. It's still going downwards, but perhaps here at the very right end, if the draining from the summit can stop, then the movement on the Upper East Rift intrusion can also stop, and then we might come to some stability. Right now, things are still stabilizing and not quite there yet. Okay, we mentioned in our summary the tilt meter at the Sand Hill Station, that both the summit and South Caldera areas are feeding it. So interesting to note that the South Caldera also is feeding magma, not just the summit. And prior, we were seeing magma inject into the Southwest Rift as well, and we'll probably see that, we'll bring up a GPS to show that that has slowed down significantly as well. Okay, so for the last month, this is even noisier, so let's keep going. But earthquakes per day, it is notable to see that we are at similar levels as we saw at the last pulse of earthquakes at the end of last month. For the last year, we now measure earthquakes per week. And so this week is our third highest count of earthquakes for the last year, as you can see here. Just behind, when is that? It's in May and in February. And this is in Southwest Rift intrusion and a buildup, maybe not quite a buildup to the June eruption here, but part of that sequence in there. So certainly a lot of earthquakes for the last 5 years. Now earthquakes per month. And this month is now the month with the most earthquakes of any month in the last 5 years, since August 2019. So we're building up lots of events, a lot of adjustment happening through lots of small earthquakes. GPS is following a similar pattern as a tilt, where the north-south distance across the caldera at the summit. Right here, when this line goes up, they're getting further away. When it goes down, they're getting closer together. So just this most recent point, showing sagging, the sides coming back closer together as a summit is losing magma to feed this intrusion. That's what you'd expect to see, a little bit of sag there. And if that stops, it might quickly then reverse directions and start swelling again. And so this may look like this, and then further up, maybe like that one, or like one of these that we've seen this pattern of movement of magma from the summit to the East Rift, usually on slightly slower timescales, usually taking a week or 2 weeks to do so rather than half a week. But that is a similar pattern we've seen in the recent past year. At Pu'o'o, there's a line north-south across caldera as well. That line is going down, so those sides are getting closer together. We have seen some extra data scattered below this line over here. When I looked earlier today, it seemed like it was more than this, actually. It seems like there's been some data correction occurring. And as that's happening, some of the data that were previously down in here seem to have corrected back into the regular trend. So maybe some noise in the data there. But if anything, those sides are getting closer together even faster. And that might be happening, in fact, and we'll have to look more closely at that. But so either it's just noise, or they're getting closer together. In any case, they are not getting further apart. So any injection of magma has not reached this area yet. Yeah, and it may be quite a while before it works its way towards doing that. But this would be how you would look. And this is why this plot exists, is to track the magma movement into that East Rift zone, right, where you see it spreading apart. This is only a horizontal signal, not vertical. So that's also important when we look at the other signals. So we will get to that, but first I thought we should review the tilt meters today. And a 2-day tilt, zoomed in even further today, it is showing maybe slightly flatter right here, but you can see it's still wiggling down a little bit. So we'll wait to call it still. We've looked at Wikahuna. Kilauea Iki is also showing some response here. So Kilauea Iki, every one of these plots has 2 lines, the green and the blue. These are 2 components. They usually point the green one or the blue one towards the closest magma inflation source. So in the case of Kilauea, that would be the summit at Halemaumau. The blue line points towards Halemaumau. And then the green line will be 90 degrees from that, which in the current orientation of Kilauea actually points towards that Upper East Rift Zone. So this is another interesting station because it's showing in the summit actually deflating there. So it actually shows if we come over here and look at the green line, the Upper East Rift line, it's actually showing this little bit of a drop. So that's the onset of activity there of the earthquake swarm and movement late on the 22nd. On the 23rd, we see the drop from the summit occurring. And then this morning, we see a change where in the Kilauea area, between Kilauea and the summit, some of the earthquakes occurs, some other little bump causes a slight reinflation, and now it seems to be deflating again. While at the same time on the rift zone, that same earthquake event seems to have led to a much larger deflation in the area of Kilauea, right? Perhaps more movement of magma from that Upper East Rift near the summit to closer to Maunaulu. Sand Hill we've looked at for the last month. The Escape Road we've looked at. Right? We haven't exactly pointed out all the different little wiggles of earthquakes and all the different pulses once again, but you can see how the pulses are expressing differently on both components, but they're present on both, just showing different directions. One thing to mention is that this is not like the ground is rising or falling like a GPS station. This is actually tilting one way or the other. So one side of it's going down, the other side is going up. And it's actually a matter of quadrants, right? So it's a matter of how much is it moving north or south or east or west, right? And then the center point is where the tilt meter would actually be. Right? So on the escape road right here, if I come back to our INSAR image right in here, and let's try to zoom this in. Oh, I may have to click a couple more times. Zoom this in. Right in here. Okay, so one of our components is a north-south component at Escape Road. The other one is an east-west component. So the north-south component is going to be measuring likely whatever this thing is pushing north-south on that instrument. And the east-west component is going to measure how far this thing gets over to this direction to cause an east push from that instrument as well at the east rift zone. So that's more or less how it sits there. And so with magma intruding here, this is going to tilt away from it, and looks like that is leading to the blue line going down in our case and the green line going up. At Pu'o'o, similarly, the blue line is pointed at the rift zone in that case, and the green one along the rift zone. So along the rift zone, looking back up rift, there's maybe some signal that's flattened out, but otherwise the actual rift zone signal itself is still deflation and no change, no surprise there. Jonica, further away, even further down the rift, is only showing lots of shaking from the earthquakes, these big spikes, tangentially showing the earthquakes coming from along the rift axis down to the lower east rift, but no significant change in tilt down there. We also have a station down at Kaina Point on the south flank, but it's just showing daily variations and nothing significant there either. So we'll come to our 2-year GPS, and this is taken off the USGS map, which we can look at for positioning in a few minutes. But I have these grouped by region already. Summit Caldera is these top 4 right here. And just to talk through how these are actually laid out, there are 3 panels. The top panel is an east-west component. The middle one is a north-south component, and the bottom one is an up and down component. And so in combination, the top 2 tells you whether this is going northeast, northwest, southeast, southwest. Right? In this case, it's going north and not east, so it's going northwest. And it's also rising upwards, right? And that's how we would read one of these. These are 2-year plots now. So when we looked at our 1-year plot at the summit and the rift zone, we were looking at about that much time. So all the data we're looking at for this eruption is going to be squeezed into just this little sliver on the right side, right in here, more than likely, as we look at these graphs. Right, so the important thing to see here is at the summit, Still rising. Let's just give us a reload here just to make sure we have everything up to date. These usually only reload once a day. So yeah, nothing new here. But the summit is still rising in the northwest, on the east, in the southwest, and in the southeast. Although it is contracting a little bit while doing so still, right? So the center is moving to the south from there, even though it's still pressurizing from below. All this because there's a really healthy magma supply coming to the volcano that's been there since 2019, really. We've known about it. We'll come to that in a little bit as well. So that's right around the summit. And if we're looking at variations within the last few days here, maybe some wiggle on the east-west component at the outlet. This is the one that is right next to the southwest rift connector, the South Caldera area. So if magma is wiggling back towards the southeast rift, then that would explain some wiggle there. On this side, we have some extra noise here on crater rim on the east-west component as well. Maybe a similar story there. Maybe it's just noise. We'll have to wait to see. Oftentimes, these are based on satellite data that get corrected after a few days. So that's why you often can have noise in the most recent data points that are using preliminary satellite orbits to do their calculations. So this is now the southwest rift, 1.5 miles southwest of the summit. You can see the ground is still rising, but it's doing so at a slightly slower rate there than it was previously. Right there. 4 miles southwest at KOSM. This is very near the eruption site. Here it's a little more clear where this has actually been rising since eruption. That was eruption of early June right there. So it's actually been rising since eruption, and just now it looks like it seems to have flattened a little bit. So perhaps the ground there stopped rising. The pressure is enough to feed the east rift and not to propagate down into here. And further down the southwest rift, still no change in any of the signals since the eruption. The south flank. Many of these south flank stations fall into that Kauai zone, so they're experiencing change as well. There's not a lot showing up on some of these plots here with the most recent data points, but you can see that up and up and up. Devil's Throat. Devil's Throat's one of the stations close to that intrusion. So the ground is getting pushed upwards there, while it's also getting pushed southeast in all these cases. Southeast, southeast, southeast. Southeast. This is slightly further away at Idaho. Makapui is a little bit further to the southeast as well. So a little bit outside of the zone, as well as is Kalapana Trail too. But some of these are showing some noisy points, and so we have to wait probably till next week to really make any conclusive analysis of this. But this could just be noise. Extra data point up here, extra data point down here. And so that seems like it may be affecting all the different components. But we have seen at Kalapana Trail, there's been this steepening downward line as that area moves further to the south. This might have been cleaned up as well, but here more data looking a little bit off trend. You can see that this station's got pushed further to the east. That trend looks like it might be real right in there, but still moving downwards. So let me finish off the south flank further to the south. Not a lot of change since the intrusions back in January. Lots of those ones as well. And then let's come to the East Rift. The East Rift, the one station I'd like to see the most would be Maunaulu. But Maunaulu does not have any recent data points on the far right side of it. And furthermore, it has a lot of extra noise and scatter that most of the other stations do not show. So hopefully the signal that comes in at Maunaulu comes in big so that it drowns out all this other noise, and we can see, for example, that it's raised up some amount of meters, something like that. We'll have to wait and see. But right now, there's nothing to see, and this data plot is not updated. At Kananui Ohamo, you're seeing some wiggle in the east-west component. And this is interesting. This is a signal you start to see. It looks like, and maybe it's noise, but it looks like there's a northward component, like Kanoyohamo, along with this relaxation, right? So it's almost like it's relaxing back to the north and the west. And that would make sense because, let me come to my map now. Okay, because here's our zone of accumulation to the northwest. It's been building up pressure for a long time. It finally was able to inject and relieve the pressure, change the center of pressure slightly. So Kanoyohamo is that one. So perhaps it's sagging back to the northwest as a result of relief. The pressure is able to make that little injection right there. So that relieves that station. Likewise, this one over here might see some relief. KERZ, slight hint of movement north and west as well. Let's come further over. Kamoamoa. There's a little hint of north and some noise as well. So we'll see how that clears up in the next week or so. But certainly there is a response of the ground in here within this rift trace to that former pressure, with maybe some relaxation happening right in there. You go a little bit further away, like Makai Makapui, and it's not quite so clear what's happening there. When you come to, let's look at Okita Station, right near to Pu'o'o. That one is showing some extra noise. There's a data point way down there, and there's one way up here. So it's really wiggling, or there's noise in the GPS data as well. But otherwise, not a whole lot of effect there. We look at the North Pu'o'o crater. This is the one of the two that measures the distance across Pu'o'o. It's showing a little bit of a northward hint, not so much the west. And the one that measures the other side, Jacuzzi, it's showing maybe a lot of west. I don't know. There's 3 data points here. Maybe they're all noise. We'll have to wait once again, but it's likely that these are data points right here that are causing what we see over here on this distance plot between those 2 stations. So we may also see that clear up too. So overall, the effect is localized to the intrusion zone. Nothing is happening really that weird further over, maybe some slight relaxation of the rift zone through here. But what I didn't point out, and I'll just put it back up so you can see it again, is here in the rift zone, we're going down, and even if we're having adjustments of the blocks of rock and they're moving slightly this way or that way, they're not moving up, right? And that's the key thing for knowing how far the magma is going, whether it's just pushing from the side or whether it's got close enough to start swelling it from below. So far it's just from the side, and everything is still in the Upper East Rift area. Okay, that's plenty of GPS. I think we've talked about the INSAR enough as well. I mean, maybe, right? You maybe can note that inflation center, maybe a little deflation center right there, maybe another inflation. There's a little bit of an arm that goes off this way. So maybe it's trying to, maybe there's some kind of structure that leads off in that direction. There's a little bit of an arm that goes off this way too. So maybe there's structure in that direction too. And you can see how those are 2 different directions, right? And that's really this bend that we're talking about right there. You really see it in this structure right here. So the question is, does this go anywhere? Or does it need to find a path that gets further over this way? Or does it need to wiggle its way to this trace? Because there's lots of cracks all through here. And we'll get into that in our segment after our break, when we talk about previous fissures, previous eruptions in the rift zone, and how that all fits into the context of what's happening now. But for now, I'll take a break and pass it over to Dane.
There we go. Yeah, so thank you, Phil. Let's go ahead and thank everybody for tuning in today. Rely on viewers like you helping get that information out there. The likes, the subscriptions, the shares, they really do help. We also want to thank the people that help make this possible. That includes the Kilauea Recovery Grant, as well as the Puna Strong through the Hawaii Community Foundation. So we appreciate them. we do have Lou joining us to give us a little update on our fundraising drive. We are in the midst of. We're about almost halfway into it now, and yeah, why don't we go ahead and pass it to Lou? Huh?
All right, Lou's going to talk for a minute. So hopefully he speaks slowly, Carrie. I apologize, forgot about this video. So here we go. Let's get this going here.
All right, gentlemen, thank you very much for giving me a chance to jump in here and say thank you to everybody. I first want to start with our grants, Kilauea Recovery Grant, Puna Strong, Hawaii Community Fund, Vai, and the Atherton family. The grant funding has been fantastic, and we appreciate all the support out there, as well as all the support from you all. There's our credits rolling. I'm not going to breeze through them all. You can see them there. Best way to support us is at hveri.org/donate, as well as the super chats here on YouTube. Thank you very much. All of our viewers across the board from X and Facebook and Instagram, wherever you may be watching us, even LinkedIn, a few of you out there, right? If you haven't followed us on LinkedIn, know that we're still striving to get up to that 150 followers so that we can broadcast live on there. So if you have a LinkedIn account, try to track us down. HVERI is the best way to do a search for us there. That's all I have for you guys for tonight. We have some options over at hveri.org/donate. You can see that right there. You can either do a one-time donation, you can do monthly or even annual. All are great. Everything helps our program of our volcano education, our community resilience programs that are going on. Stick around. There's more to come. I'm sure Dana Phil will have more of a broadcast going on tonight. So thanks, guys. Thank you all for joining us. Aloha.
All right. So yeah, thank you, Lou, for giving us that brief update. We did have a couple more donations come through. We had, Tim just donated two $50 donations through Super Chat. Just a sticker attached to those. We appreciate those there, Tim. And we also had a $2 donation or $1.99 donation from Ken through Super Chat tonight. So appreciate all the support there. Mahalo, Tim. And yeah, I believe that gets us through everything. Again, you can make donations. These are tax deductible because we are a 501c3 nonprofit that are made through our website, which is hveri.org/donate. All right, Phil, I think we can go ahead. We got a bunch of questions lined up, by the way.
All right, yeah. So I got one segment here coming right up that I wanted to put out before we get to the questions. So this is really the meat of the second half here is what's coming up. So we'll call it volcano awareness, I suppose, here, just for context.
All right.
So let's pull up this page from Professional Paper 1350. This was from the 80s, commemorating 75 years of HVO. And what this is showing us is in pink is intrusions, in black, brief eruptions, and kind of grayish sustained eruptions. And it has different about 5-year periods here. So 55 to 59, 60 to 64, 65 to 69, 70 to 74, 75 to 79, and 80 to 84 here, all different periods of time. And what I want to point out to you is that some periods of time have a lot more pink in them, and you can see where these intrusions actually occur is Southwest Rift, Kauai. There's a bunch more as well. Sometimes you get into this Upper East Rift, the uppermost Middle East Rift right in there, Southwest Rift all through here. So you can see that this pattern of intrusion through this Upper East Rift area is actually fairly common through many decades of Kilauea's past, all through here. We mentioned there was a volcano watch a couple weeks ago that talked about various eruptions along the Chain of Craters Road, and we'll follow up more on this next week as well. But beyond just the eruptions that are shown on this map, restricted to the Upper East Rift connector right through here, what else is the context of Kilauea in this time? So I thought the best way to do this would be to open up Google Earth for you guys and start putting on some shapes of old lava flows on here. So Google Earth, here is our current earthquakes. I'm going to take them off so we can see the lava flows. And I'm going to go back to, I'm going to choose 1962 in December as a first flow for us to look at. right? And all these are just breakouts from this area from various different scenarios of magma pressurizing this area. And so just leave it at that. And just look at the traces of what actually made it out of the ground and when and where. So December of 62, right here, that was an eruption in the old, there used to be an old crater called Aloe over here. That's the trace of that. Before Maunaulu was present in this area of fume, there were a couple little spots of eruption there too. And the third one over here. And 3 more getting close to the edge of Makapui and Kananiohamo. One thing you can notice is that there are 2 different strands. You can see this one trend, and then it steps over to a second trend. And this is common pattern you see for the stepping fault lines moving down the East Rift here. And that's part of the complication of why it's not necessarily so easy for the magma to just go in here. And it's not necessarily one big pipe that goes all the way. It may be in areas where the Pu'u eruption has worn it out so it can remain as open as possible through 6 years of cooling, stagnation, hardening, and collapse. But it could also have to renegotiate some of these bends and corners to connect these longer fault strands here. So that was December 62. The one that follows that is August of 63. Come on, there it is, right there. That one occurs right along the old Alai crater, right along the upper rim, down a wall of the crater, pours a flow, makes a lava lake in a crater, famously studied lava lake of Alai crater of this eruption, August of 63. Only, I want to say it was 40 days later, about 40 days later, October of 63, we have another eruption further down the rift. Let me zoom this out a little bit, redisplay it, starting at Pauahi Crater, and further over past today's Pu'u, past Pu'ukia'i, all the way to the edge of the forest in that really, truly Middle East Rift Zone. There was an eruption in October of 63. So here's as far as it went. And you can imagine that if this were happening today, people would be more worried further down the rift that it's just going to keep coming down, keep coming down, keep coming down. But that's not the pattern that actually occurred. And so after 63, 65 December is right in there. Let me zoom it in so you can see it a little better. 65 December comes in right in here. Right, so a little more closely, not that far off of the 62 eruption site. 65 March. Zoom it out some more. 65 March, you see, goes to the Middle East Rift near Pu'u once again, right through there, but no further. And then in 67 to 68, we have 9 months of lava lake at Halemau. So it's blocked. The easiest path out's at the summit, not unlike what we've seen recently here at Kilauea. And then following that, it's going to resume its activity down the East Rift Zone. So let's zoom back into the East Rift. And let's go to August of 68. August 68, where are you? Did you see it? Comes in right in there. August of 68. Zoom it in more. Another one of these leaking, like a leakage of an eruption rather than a real outflow of lava. A few little cracks, including at the bottom of Hiyaka crater here. All right, zoom it out a little more. 68 October to November. That's once again back over here. Whoops. Comes in that same zone that seems to be reactivating over and over between Napau and Pu'u, Kamomoa area right in there. 69 February. Let's put that one up. There it is again. See lots of eruptions without summit intervals. All little segments of the rift zone. These were all very short eruptions occurring all through here. 69 February. The big one that comes and lasts a long time after this is Maunaulu. Maunaulu, I'll flip it on here briefly. Is that big scar there? That's when it parked itself for a good 5 years with an intermission. Right there, left that big scar. So that's not what we're talking about today. I'm going to leave that one off of there. We're looking at situations where this Upper East Rift and Kauai might be actually cracking and leaking out. So we'll move to 71, August, which we've talked about in context of the summit, right? Because now we're bringing in the Southwest Rift as well, August and September of 71, summit Southwest Rift sequence. Then we have May of 73, right here, that Hawaiian Crater once again in the middle of Maunaulu also. November, December of 73, another eruption right through here. Let me show you those two again. Let's pull those two back, 73 and 73. 73 May, Hawaiian Crater and Pauahi both. 73 November to December was Pauahi all the way further east. All right. July of 74 is in the summit, Koʻokoʻolau area. We talked about this last week. September of 74 is in the summit sequence that followed right through here. And then December 74, the Southwest Rift eruption, similar to the one we just saw in June 3rd. In a very similar location, not nearly as long and far though. Right, so the pattern is starting to emerge here, right, of what happens. These summit eruptions. November of 75 was a summit eruption. 77 was the one where the magma moved without earthquakes from this area to where that erupted. And I'll put that on here. Let's zoom it out so you can see where it goes. 77, September to October, is that one over there. So Pu'ukiai sent one flow towards Kalapana, stopped before it reached the coastal plain on the Pali still. But that's a distinct landmark for people down in Kalapana. And that was the closest it came towards houses, was that one flow right there in 77. 79 is over here at Pauahi again. 79 right there. You see it there, there, and there. November 79. And then 1980 in March. I'm going to zoom it back out. Where's my March 1980? It was hard to see that one. March 1980. Little leakage right there. 82, April to May. That's in the summit. Fissure right here. 82 September in the summit also. And then you get to the pool hole era, which is then going to be that whole mess over there. Right. So apart from Pu'o'o and Maunaulu, take those two off when it parks someplace and we know it's going to stay there. And apart from, zoom it out a little more, 2018, all the way down there, usually what happens is it stays in this Middle East rift for much of this history of the volcano. And so in this history of what we have on the GIS here, that's the pattern of it. So we've seen similar Southwest Rift as 1974. We've seen pressurization at the summit. We're now seeing pressurization on the East Rift, especially in this area where it turns and makes a bend. So I just wanted to show what those eruptions look like. Sometimes little patches in the middle of nowhere, just leaking out of the cracks. Sometimes slightly longer fissures, like this one, leading to slightly longer flows. Sometimes they eventually migrate to this Middle East Rift area around Pu'o'o to Nepal. And once in a great while from that, may they put a lot of flow down towards where there already is lava covering the ground. So that's a little bit of the context of where the flows have gone in the past. This is like, the history since 1962, right? So that's a long time of context for us to have perspective here on what might happen in the next few days and weeks and months, right? Because it may be that we have an intrusion today and we have some transition period and then an eruption follows within weeks or months. Okay, so that's what we're looking at that. And so in the context of that, I wanted to come back to some more of our monitoring data and share the summit tilt plot that goes back to the 1950s. So let me make this slightly bigger here as well. And in light gray is superimposed on here, the 2018 level. So here, the 2018, it drops to here, comes back up, and somewhere around this 300 microradian mark, with this caveat that it could be off quite a bit too. So what you can see is 2018 was a massive, massive drop, right, of the tilt. The summit tilt rises. It gets relieved when a magma goes and leaves, in this case, to Kapoho in 1960, or goes down to the East Rift and causes an eruption. You have these drop-offs, right? So you can see the absolute level. Maunaulu was near the highest level of inflation in this entire record of lava, right? Of eruptions of Kilauea since '56. So since 2023, I thought we could add a little bit more. We actually have here this slide that came from the USGS also. This goes back 4 years. So we know that from 2023 is this segment right in here. Starts off maybe at around 50 microradians and might end close to 150. So I might maybe add another 100 microradians there. And that's through the end of, what is that? Yeah, through the end of 2023. Right in there too, right? So, and then this year, in 2024, we've come up a ways as well. I don't have a one-year tilt plot, but I would guess maybe in order of 200 microradians or so. So we may be close to somewhere in here as far as our level of tilt, which is, with a caveat, not too far off what we were before 2018, but still significantly less than we were during this era when we were having these intrusions and such in that Upper East Rift zone right through there. So it's a different story since 2018. It's not the same pattern as before, right? We have to kind of reset and consider it as a whole new chapter here. And following 2018, we saw from this paper, what happened here? Where was my paper? Okay, well, I don't have that paper there. Let's see, that was paper by Mike Poland, post-gravity filling of the summit. So I have this image somewhere else, but I'm not sure if I can find it here in time. So what happened, what this paper is supposed to show us, is that there was a survey done with gravity. I want to say it was in September 2018, not long after the eruption was over. And there was another survey done in March 2019. And in between those two times, they measured an increase of gravity at Kilauea summit before there was any signal on the GPS or the tilt meter. So we know magma was coming into the volcano already very quickly after 2018. And by April 2019, there began to be tilt and GPS signals showing inflation on Kilauea summit. So we know that's when we knew that the supply of magma to Kilauea was very, very, very healthy, right? It was very strong from before 2018 to build up the whole pool eruption, to cause a new opening of event at Halemaumau at the summit, to sustain 2 eruptions at the same time, and have them both overflowing at the same time, and then having one almost congealing and hardening, so the pressure backed up. All of that was that buildup from all the magma supply being healthy into Kilauea. And the question really was, after that collapse of the summit in 2018, would there be a top-down effect where maybe you stop having so much magma supply, or would it pull more magma up instead? And what we saw was that in those first few months, when a gravity was being measured to be increasing, the magma was filling back in, the supply rate was actually pretty low. It was pretty low. It was kind of still trickling in. But then following that, when we see it actually filling all the void space and engaging the rocks to start pushing them and cause GPS to move and the tilt meters to move, that's when they see the supply rate start to go up. And we now know that. It's pretty obvious if I tell you we've had 6 eruptions in the last 5 years on Kilauea, then it's a pretty good indication there's a lot of magma coming into the system, and our eruptions are not relieving the supply. All right, so that's what I wanted to show here. And then one other caveat to talk about, like how and why and what are the factors involved here. The big one is, another one is the south flank. We talk about whether the south flank pulls and creates space, or whether the magma pushes and makes its own space, which one is in the driver's seat at any given moment in time. Right now we have a lot of magma pressure, supply rate is high, but it's worth mentioning the south flank has been moving steadily since 2018 as well. We've been talking about on our earthquake maps, south flank background activity is normal every single week, every single month. It's been ongoing. And so this paper, which is from 2020, looks at periodic intrusions of Kilauea driven by south flank movement, right? And so they've pulled out a couple of intrusions here. 2007, the one of Father's Day, one mentioned by the USGS. 2011, the one I mentioned from Kamoamoa as well. There's two different panels here. This upper panel A is a map view, right? So there's Hawaiian Crater, Pauahi Crater, Maunaulu, Makapui, Nepal, Pu'o would be over here, right? That's where that looks. And then the cross section is this panel below. So the surface is 0. Also here, this is the top of the ground. Down to 6 kilometers down. Right in here, 1 to 3 kilometers is where the rift zone is thought to be. Here are the black dots of the earthquakes. In detail, there may actually be 2 pathways, a 3-kilometer pathway and a 1.5-kilometer pathway, more or less in there. There's not really, the detail isn't quite known. Hopefully the seismic survey USGS did last year and the year before will help clear up what's going on with that. But from this region and through here is where magma originates, with the lowest possible flow path down here in this gray. They've noted by the earthquakes, where there's lack of earthquakes is more important because those are potential magma storage areas. There's one known to be between Hiaka and Pauahi. There was one perhaps transient one, perhaps not there anymore, one at Maunaulu that was only active during the Maunaulu eruption. So this is a big question mark on that one. But no earthquakes there either. There is definitely one in Makapui that was most recently seen to drain in a 2018 collapse and intrusion of magma. This area was seen to deflate more so than other parts of the rift, right? And those are the ones marked on here. So in 2007, perhaps from this pathway area is where this dike went upwards, or perhaps from that Maunaulu storage, although it seems to be kind of off to the side there. And the Makapui Reservoir, this one right here, maybe that's the source of that one and of that one, right? What you can't see, so the cross section is interesting. You can see that this reservoir seems to connect both of these areas there and there. But on a map trace, these are actually 2 offset lines, as we pointed out before. So this storage area is bridging the gap. It's allowing it to step over here to resume this other trace. And it can cause injections either way. So if it can get to here, to this reservoir somehow, then maybe it can do something more concerning or more interesting in that area. Right? So that's the possible pathways of magma. And you can see the 2011 one was really interesting, how it started off deeper down and progressed laterally and upwards at the same time before turning and heading straight up once it got to Kamoamoa, east of Nepal area, right? Perhaps there's some kind of old dikes and stuff in here that are some harder rock that corralled it around to deflect it over there. So there can be all kinds of hard spots in there, old cooled rocks. Generally speaking, rocks can break more easily if they get full of bubbles, vesicles, gas dissolved in lava. If you have a dike that intrudes underground and it intrudes deep down and doesn't come to the surface, then you may not have any bubbles forming within it at all. So that rock is a solid, hard, dense rock that's like a scar tissue within the earth that is hard to break through. So if you're a new dike trying to come through, you avoid the old ones. You go through the areas that have not had all that cold, hard, dense, bubble-free rock. And those could be what actually cause these blockages that express seismically in the area, right? So you have a seismic pathway and you have seismic gaps, a seismic barrier, and more seismic barriers through here. And perhaps that has to do with this history of intrusion through this whole area. So between that, between having magma, let's think post 2018, between having magma that drained from the summit to the lower rift zone in 2018. It didn't all come out. There was some remnant left in the rift zone after the fact. It's been 6 years of it sitting there stagnant, not moving. How much has hardened, become solid, and is no longer actual space? How deep down did it go? How deep is that space? Is there space shallower or deeper? Those are all questions that we have no answers to, that we can maybe answer better after we have magma moving through the system to see what actually happened. But right now, there could be constriction of collapse, constriction of cooling magma, constriction of having not cooled, but degassed old, very viscous magma, perhaps, of having disconnected fault strands. All those things could be what's actually blocking the movement of magma from the Upper East Rift into the Middle East Rift. And that's the work that's going to have to do over the next series of intrusions, eruptions, whether that's weeks, months, years, or what have you. That's what has to happen next, right? And we don't know exactly the pattern in which that occurs. The thing that was interesting about this that I wanted to point out, the south flank role in this, is they noted that the Upper East Rift, look right here. So they actually pointed out 3 different strands: Upper East Rift Zone, Makapuhi strand, and a Napau strand. And they each seem to activate with different recurrence. It turns out that the Napau and Makapuhi area, periodically, this is during Pu'o'o, right? So magma is kind of flowing through there. It has an outlet. It doesn't have to build up anywhere. So why would you have extra intrusions? And they're noting that every 14 years, the rift zone moves enough to create enough tensile stress to allow intrusions to occur. Most of the magma is intruding in this black dike, steady state rift opening. But as the flank keeps moving and moving and moving, it creates this zone of low stress above the rift zone. And eventually, after enough years, you get to 5 megapascals, which is your threshold for breakage. Then you can break and cause an injection. And so just naturally, by the flank moving by itself, you'd expect every 14 years an intrusion on a Middle East Rift. On the Upper East Rift, actually, this zone of the south flank moves faster than this zone. Normally, even before this post-18 era, it's about every 7 or 8 years or so that occurs. Right? So they haven't quite put every single one. They really, like I said, the Kamomoa, I guess, is 2011 in here, but they don't have the 2014 one. So the rift zone the south flank is always moving, causing this area to open and causing magma to want to inject, right? So that's also going on for the last 6 years since 2018, combined with an extra magma supply, combined with this development of movement of the south flank that's causing injection. And that's what's got us to where we are today, right? And so we kind of saw this coming, even, when we had I remember New Year's Day, or, was when we New Year's Eve last year, we were talking about what might happen this coming year in 2024. And top of the list was East Rift Zone, a re-intrusion, a reoccupation. And here we are halfway through 2024, and we're seeing it happen. Most likely stays an intrusion, but that would lead to more intrusions. And eventually you get 1 out of 10 that does erupt. And that can happen anytime. So that's the little extra volcanic awareness presentation. I think we need to, as usual, look at our volcanic hazards, which are the gas here in Kilauea. We'll refer back to the VOG measurement and prediction project from UH Manoa, who we often rely on. They have this VOG forecast dashboard, and with eruption, with a gas site at Kilauea at 300 tons per day, this is the actual dispersal pattern of VOG across the island. So mostly it stays to the southwest in areas where people are used to it being there, although they may be sensitive and need to be cautious about it if they are sensitive, especially. In a national park where people are all crammed in, presently the Chain of Craters Road is closed. So everyone's crammed into the summit area all through here, try to catch views of what's changing. Good air all through there at present. And if we look at the charts, you can see it's been good up there all day. So certainly take precautions if you're sensitive and follow ranger directions there. So not much as far as a hazard on Kilauea. No increased hazard from this activity to people on the Lower East Rift. It's just the gas is the biggest hazard still. And that's really it for Kilauea. And very quickly, Mauna Loa. Mauna Loa is showing its tilt variations day to day. That's normal. Very few earthquakes still happening. This is the last week, so they are still happening. There was one deep one. There's not none, right? So it's a little more active than some weeks, but really it's still the background. As far as the tilt, pretty steady overall. Maybe some little wiggle through here, but it's pretty minor, and it's hard to link that to anything happening on Kilauea decisively here. If we look at earthquakes per day, we reached 8 this week. So that's where it looks a little bit more busy in the graph, but overall it's still only 8, where it's very, very few earthquakes in the context of earthquakes per week for the last year. We're still nowhere near even the deep earthquake swarm we had, which doesn't even compare to our pre-eruption buildup back in 2022, which in earthquakes per month was reaching over 1,000. Now we're down in the, it's probably 50 or so earthquakes each month. So very quiet on Mauna Loa, still recharging, but nothing unusual happening there. So we'll turn to our community corner next year. And I mentioned the national park impacts of this. So the national park actually back on July 1st released this release to expect temporary area closures if unrest continued. This was when that original earthquake swarm occurred back in the beginning of the month. And this week, on the 22nd, there were temporary closures as a result of earthquakes happening. Here's a map at the time of the closures. Closures include Chain of Critters Road from the intersection of Devastation Trail parking lot all the way to the coast. Now Kauai Campground is closed. Critter Room Trail south of Nahuku Lava Tube closed. Coastal backcountry areas and Nepal closed. All backcountry permits canceled. Escape Road was also closed from Nahuku to Maunaulu. So that's a whole bunch of areas, and basically what's still open is the summit and lava tube areas. Still, Koʻokoʻolau is also open. So all through here essentially. That is the update from the national park. So if activity does die off, maybe they will reopen it fairly quickly, but they may wait to make sure it actually is over. So I would not expect any change before tomorrow at the earliest. And really the next 24 hours may tell us whether this resumes or stabilizes and stops. So a couple more community points. We do have an update from Kilauea Recovery. There was a video last week, of course, but here's the most recent update. They are, let's see here. Can I scroll this? Oh. Maybe it's too zoomed in. Let's go up. Oh, can't get that to work, Dane. Oh, there it is. All right. Stage 1, Four Corners Pohuiki. They have got notice to proceed in June. They're having a public blessing at the end of August. Construction expected completed by March 2026. For Pohuiki Road, all the access has been secured. They're expecting by the end of this month completion of design and to put out bids. Expecting to award by September and to construct after that. So maybe by the end of the year, and expected to last 18 months. Pohuiki Road. The bottom of Pohuiki Road to Mackenzie, this is that Mackenzie flow. That's within 12 months. That's kind of one of the last things, stage 3 there. The actual last thing will be Lighthouse Road over here, 700 feet to reconnect, but also allowing more time to address Kumakahi stewardship plan. So that is the update. There is the timeline of different phases of the construction there from Kilauea Recovery. So we'll await actual images of anything happening to share with you guys, whether it's the blessing in August. That might be the next thing that we have coming up here. So final item here is that we did attend the La Ohana or Pohoiki Festival last weekend, Dane and I, at Isaac Hale Beach Park at Pohoiki. There was live music, lots of Hawaiian culture, craft vendors, food. What did you think, Dane? What are you going to say about that?
Yeah, the music was really a highlight down there too. You know, just to have all these great musicians playing all day, and a lot of people to talk to. A lot of people. Felt like we could have used another person really with how many people we were talking to that day. But yeah, great to see everybody back down there at Pauahi again to do something before all the construction starts up and the dredging and the park redo. And Pauahi's going to be busy for a while, and hopefully at the end of it, it's better, or at least a substitute if there could be one for the old Pauahi. It's what we can do.
Yeah, for sure. Yeah, so it was great to be down there with all the Puna Ohana, and shout out to all of you guys and all of our partner nonprofits that are doing lots of good work down in this area. So that's really it for our community corner and what I've got, Dane. We're going to get to some questions.
Yeah, try and tackle a few of them. I have tried to take on some of them in chat, so bear with me here. So let's start off with a question from Nicholas, and this is kind of a two-parter, but is there any approximately how many million cubic meters have intruded so far? And is, maybe you don't know, but is this a smaller dip or a comparable dip to 2018?
So we don't know the exact number. That's something that has to come out from modeling that the USGS does. I don't have all my spreadsheets and things set up and all the data quite so easy. So we'll have to wait for them to give us an actual volume. No point in guessing, right? But compared to 2018 was much bigger than this, regardless of what that actually comes out to, because 2018 was just off the scales to anything we normally see. So that part's easy to answer as far as a volume.
All right,
but we'll have to wait. Yeah, we just we had the one INSAR, right? And one thing I did not mention is this INSAR image. Let me pull it up here again. This one, right? This was up through 6:10 a.m. yesterday. So this did not catch the third or fourth pulses that went further east and further west. So there's still some question here exactly of how much further did it go, how much bigger did it actually look, how much did it raise the ground up. Hard to know those things. So when we have another pass of imagery and we have a more complete picture, somewhat, because these areas that are all grayish are gray because they're covered by forest and you're not going to get data there regardless. But maybe you can catch a little bit more of what's going on. You can see the shape maybe change a little more to something like that if it really did move southwest and southeast. And then from that, combined with the GPS data and a tilt meters, then you can do a model that tells you how many million cubic meters. Yeah, but I don't have an answer.
So Victoria asks, all those earthquakes give me the impression that magma is just a few hundred feet from the surface already. Is it?
No, I mean, I think the earthquakes can happen. So the earthquakes are happening in solid rock, right? And the magma is pushing that solid rock. And the solid rock can break, let's say your magma is like down here and you're pushing a rock above it all through here. The rock can break anywhere here or here or here or here, all the way to the top. It can break anywhere within that stack. And so where rock breaks is telling you more about where are the conditions right for rock to break, that is important because that tells you, can you get a pathway all the way to the surface, right? So having earthquakes that are shallow does matter, but those earthquakes that are shallow are not themselves directly the magma coming up. So that's part of it. And the other part of it is just kind of understanding the structure of the area, which just comes with study of it, right? To know that this part of the rift zone here does not usually erupt to the surface, and it has a vertical component where this whole piece of land can rise up and down, but it also has this strike slip component where it actually is going to move south while this piece of land is relatively moving north, right? So it's got this back and forth, like the San Andreas Fault kind of movement going on it also, right? Back and forth. So there are lots of reasons and lots of surfaces to catch and to create earthquakes and to fall and crack as well. And maybe more important is like where the magma has historically shown that it has a chance to move through, and which pathways can it then utilize to go somewhere. And that's what the rift zone actually is that combination overlap of your cracked fault line and your magma pathway right through there. So I'm not sure if I answered the question fully. I don't see it up here anymore, Dane.
Yeah, you got it.
Remind me.
Here, I can put it back up for you. But yeah, I think you got it.
Yeah.
All right.
Yes.
Moving on to the next one from Buster Brown.
Let me just follow. Oh, real quick follow up. If it is within a few hundred feet of the surface, you're probably going to see steam and gas as well, right? That's the first thing that happens before magma comes out. So if it's coming out first, you start seeing gas, then it's a pretty good sign.
Yeah. I might have a last question for you, a special one. All right. So, but first, Buster Brown asks, is it possible that earthquakes east of Maunaulu was caused by stress being put on the underground structure of Maunaulu itself?
I think it's, yeah, maybe it's possible. I mean, I don't know what the underground structure exactly is. We talked about how there was maybe a remnant magma chamber there. We talked about how there's a lot of dikes in this area, and maybe that conjunction of all the dikes is that structure that's more rigid. It kind of depends on how the stress and the pressure intersects those as well, right? Like, so if you imagine something that's like a blade, if you're catching it on end, you can push it. If you're catching it flat, you're not going to, right? So kind of depending on if you have a particular coherent dense rock at depth at the right orientation, that could propagate it too. But yeah, I mean, I think really it's, you know, when we see, for example, stations all the way over here potentially responding, slacking to the northwest, it's showing you how much stress is across the entire system, right? So if this can just settle, like, you know, just kind of very gently settle back to the northwest all the way over here, then anything in this area could certainly be affected by the buildup of pressure over here in this intrusion area, whether it's further up the rift or whether it's at the bend itself, either way. But I do think you're right, Buster. I think that there is certainly stress transferring east to Maunaulu, whether it's directly through, whether it's through here, I mean, whatever. Let me put on more earthquakes here so that you can actually see a little better, right? This whole cluster of earthquakes east of Maunaulu. Yeah. That's the big question there, is that, you know, is that stress coming from a main pathway that can reconnect into other parts of the rift zone here? Or is it one of these dead end strands that's further up, right? And maybe if magma is in one of those, it's pushing over here also, but it's not going to lead to anything in that case. And if it's doing that in a more established pathway, then it could lead to something else.
All right. And then Bill asks, does the more or less continuous inflation in the summit area add up over millennia to gradual increase in the mountain's height, or do the inflation deflations end up averaging out?
That's a great question. That's hard to
talk about that before.
It's hard to quantify, right? I mean, this is more of like a thought exercise, honestly, because in practice, the tilt meters themselves have a physical limit, and then they recalibrate them, and then, right, that's how they deal with that. But so what you're really looking at is your big collapses compared to your continuous inflation is how I would think of it, because you're losing a lot of tilt during your collapses, right? So yeah, it might average out, but it's kind of hard to say. I think, I mean, to pick, you know, we can probably go along. I'm going to try to keep it fairly simple, but I just open this pathway, this doorway here, this window here. So I mean, the mountain is growing in height, right? and it's doing it. So like the mountain is growing, if the mountain is swollen and it's tilted out, then the next flow that comes on top of that tilted ground is going to be slightly flatter, and it's going to actually correspond to a new tilt, right? So your flows aren't all perfectly flat across the flank of the volcano. There may actually be some kind of radial angular effect happening there because of that. Well, we won't get any more detail on that.
Right.
But just to say that, yeah, that the mountain is growing by accumulation of lava, and the lava's orientation is also changing through time because of the tilt, is how I would think of it.
It almost, just a quick substitute on that might make it more accurate. Increase the mountain's width as opposed to height. We have the south flank moving further south type of thing. I don't know. Maybe it's different way of thinking about it. It's not really increasing the height.
Right. I mean, I can see why he does inflation, because if you do the width, then the south flank will move that without any magma having any effect whatsoever. Now you're not measuring what you want to measure, right? Which is the actual impact of that. Yes, it's a great question. Yeah, would have to do some more analysis of that. But good one, Bill.
So the last question I sent you on Telegram a link to, and this was a video that we got submitted just now about on Highway 130 near mile marker 15, and that's where roughly where the 1955 steam vents are. And there's just a report of steam off the highway. You can see the dead vegetation in that little spot and some heat coming up. And the person that submits it, Ashley, says that she's been here since 2020 and hasn't seen something like this before. So I was curious as to get your reaction potentially.
Well, so this area, let me pull the map back up. Where's my map? Well, maybe I should need to go to my Google Earth, because this is way over here.
Way over.
So let's put up the 2018 lava flows. The 2018 lava flows were known to have crossed very shallowly under Highway 130, right through here, right near Kamaʻili Road. And we know that from various USGS write-ups since then that the magma might have gotten within 50 yards maybe of the surface, something like that, or maybe a couple hundred feet.
Something like that, a couple hundred feet.
It was pretty close. And the area, not just there, but I would kind of draw, I don't know, very generally, like maybe like that whole area there, maybe even further this way, right, has had lots of cracks and lots of steam with extra gas coming out for a long time, because the magma got so shallow there, right? And it actually caused cracks to the surface. It would have erupted here had it not had a pathway out to get swept up in basically the flush of magma out of Ahu'ela'au and Fissure 8. It would have erupted here. That's how, if it didn't have a pathway open further down, it would have come out of the ground here. So it caused the cracks to the surface. It put out gas to the surface. It deformed the surface. It was very shallow. It just didn't actually put lava on the surface right here. But it's as if this area had actually erupted in a lot of ways, where we've heard, even this past weekend at Pohuiki, that there's continuing movement of the cracks, continuing adjustment of fume coming out of this area at Alaʻili Road. And we do know that USGS is involved. We do know that USGS is going out there and sampling soon, and have been recently as well. So they are aware of what's happening. As far as I'm aware, all of this still falls into that settling pattern, because there is no other intrusion of magma through here. There's no fresh magma coming in here. None of the tilt meters or GPS stations or anything are showing any kind of resurgence or anything like that. Now, as the ground cools and contracts, it can be cracking. The cracks can move. And as cracks move, whether through that or other processes, I mean, maybe even water, you may have the steam migrating as well, right? Along this stretch of road is where the steam vents from the 55 eruption were, right? That stopped putting out steam in 2018. Right? I don't remember if there's a name to those places. What's the area? There's an old steam vent down on Highway 130, and used to be a little trail, and the people used to go down there, and the land was contentious, and people got hurt there even. I forget the name of that place, but there were old steam vents from the 55 eruption, which are now not an issue because they're not putting out steam anymore since the pathways changed in 2018. So that's to say that pathways in this area are dynamic. They can change. Right. So I would think that maybe the gas is just coming out of a slightly different crack. It's evolving, and somehow as the ground is settling, maybe it's adjusting where the gas can come out. There's still hot material down there. It's probably all hardened by now, but that material will be hot for decades still, and there could be steam there for decades. The 55 steam vents were steaming until 2018. So more than 60 years.
And I think they still do on occasion too. And that's in that area where you're flirting between the two lines and everything's gray. So yeah, steam. And we've seen it in Leilani, the steam migrating from crack to crack, moving, even with little earthquakes that would happen. Steam would come out of a slightly different spot. Just a lot of the living on the volcano adjustments, especially when you're on the rift zone post-eruption. All right. Well, I'd like to thank everybody for joining in. I think that does it for all of our questions today. I'd like to thank our ASL interpreters. We were joined by Joel. Hi, Joel, who is a visiting ASL interpreter helping us out today. So we appreciate him, as well as Carrie and Dano, as always.
All right. Yeah. Thank you, ASL interpreters. And thank you to all of our viewing audience who's stuck with us through our extra long update today to address all these topics and activity. And
seems warranted.
I cut a lot of stuff out, which I'll just leave for maybe more historical context. We can do more historical context of the eruptions in Upper East Rift in the weeks to come, if the volcano allows us. All right, so yeah, thanks for being with us. We'll play our outro here shortly, but otherwise, we'll be back with you guys next Thursday at 5 o'clock Hawaiian time, our normal time. If something does occur, like some new phase that leads to an eruption, we'll pop in ahead of time. Otherwise, we are still posting text updates and informational updates on Hawaii Tracker and our various social media feeds. Anything else on that, Dane, or good to wrap it here?
Yeah, I think that's about it. We'll be posting those text updates across our feed. So if there's something that happens, but it's not an eruption or not that significant, look for a text post maybe on Hawaii Tracker or on our YouTube as under the post section.
Right on. Well, thanks, Dane. Thanks, everybody. From our nonprofit, HVERI, the Hawaiian Volcano Education and Resilience Institute.
You're right.
I'm sorry, did I cut out there?
No, I think just
we
had Joel freeze.
All right. So from the Hawaiian Volcano Education and Institute, HVERI, a nonprofit, and geologist Philip Wong, and our ASL interpreters. Until next week, mahalo, everybody.